Assalamualaikum warahmatullahi wabarakatuh. My name is Putra Shahzad Bahani and I am from Group 13, and our presentation title is about hydraulic pumps. Before I start, I want to introduce you to our team members, and one of them is Muhammad Syami Faiz bin Muhammad Safri, and then Muhammad Al-Fatih bin Muhammad Azmi, and Muhammad Nur Haziq Danish bin Isham. Let's look at what is hydraulic pumps. Hydraulic pumps is a mechanism that converts mechanical movement into hydraulic energy. Hydraulic pumps consist gears or pistons, and it use fluid like oil or water as it is nearly incompressible, making it suitable for hydraulic system as they can store a big amount of energy. Other than that, hydraulic system can generate high pressure fluid to operate hydraulic machinery, and the operation of hydraulics is based on Pascal's law, which is P equal to F over A, or pressure equal to force over area. Pascal also stated that the external static pressure applied on a confined liquid is distributed or transmitted evenly throughout the liquid in all directions.
Hi, I'm Haziq. So there are four major components to operate basic hydraulic pumps, which is hydraulic pump reservoir, hydraulic pumps, hydraulic pump actuator, and hydraulic pump valve. Hydraulic pumps reservoir is used to hold liquid, transfer heat from system, permit solid pollutant to settle, and help in releasing moisture and air from liquid. The function of hydraulic pumps is to change the mechanical energy into hydraulic energy by movement of liquid, which is served as transmission medium. Meanwhile, hydraulic pump's actuator is the point where the hydraulic energy is transformed back into mechanical energy by using hydraulic cylinder with linear movement and work of hydraulic motor. Lastly, is about hydraulic pump's valve is to control start, stop, and direct liquid flow in the system. This component can be actuated hydraulically, pneumatically, manually, electrically, and mechanically. So there are types of application of hydraulic pumps to operate the machine for our technology, such as aircraft flaps, car brakes, and aircraft power transferring unit, and much more. So we are looking the aircraft flaps using hydraulic pumps can deploy and retract the aircraft flaps to make the plane more maneuverable and to move and stabilize the plane safely. The second one is the car brakes make the car slow down smoothly without any malfunction when stopped the car and make the car safely to drive. Lastly is about aircraft power transferring unit, which is using hydraulic pumps can transfer the hydraulic power from the aircraft hydraulic system to another system that had been turned off before inside the aircraft to operate another system of the aircraft. So that's it from me. Thank you.
Now let's look at the construction and design feature of hydraulic pumps. There are a variety of hydraulic pumps, and each one of them is different in terms of design and feature. And types of hydraulic pumps are gear pumps, rotary vane pumps, screw pumps, bend axis pumps, inline axial pistons, and lastly radial piston pumps.
First one is gear pumps. This pump is consists of two set of gears, driving gears and driven gear. Okay. Driving gear are connected to electrical source. Okay. The action of rotation function as a heat transfer from inlet to the outlet. Okay. There are two types of gear pumps, which is internal gear pumps and external gear pump. The feature that were to mention is gear pumps are compact and simple with fewer number of moving parts. Next, we have a rotary vane pump. Okay. Rotary vane pump is a type of pump that are self-cleaning. This means that vacuum present when the rotor is rotating and sucking in hydraulic fluid and move gases without the need of manual cleaning. The main feature of this pump is it contains two or more chambers that compress, rotate, discharge gases and liquid.
Screw pump. Screw pump is a type of positive displacement pump. Consists two or more screws that intermesh each other to pressurized fluids to move them through the system. One shaft will must be the power input shaft, and the others will be controlled by timing gears. The main feature of this screw pump is it has a constant flow rate and controllable outputs. It's also capable of self-priming. Bend axis pump. Bend axis pump use pistons and cylinders that rotate around the center. Bend axis pump allow the transmission of energy at angle without energy drawback. Piston and shaft inside the cylinder move in and out because they are sliding upon variable angle. As the piston rotate, they alternate between being connected to inlet port and outlet port. The main feature of this pump is that it can operate at 40-degree angle or more.
Now let's look at the inline axial piston pumps. Inline pumps use fixed angle swash plates instead of a wobble plate. The pistons are not spring loaded and instead they are actually held against the swash plates. What is swash plate? Swash plates function is to translate linear actuation into a rotational motion. And the main feature of this pump that it can operate at high pressure and speed and vary the outputs according to the loads applied. Lastly, we are going to look at the radial piston pump. Radial piston pumps work by having an eccentric shaft that causes each stroke of each piston in circular configuration. Hydraulic fluid under pressure from a pump is fed to each piston through fluid path in the crankshaft and pressurizing the piston with direct hydraulic pressure from the fluid. When combined with the offset shaft, it produces a turning movement. The main feature of this type of pump is that it does not require the use of gears, making it simpler in design and repair.
Now let's move to component symbol and purpose. As you can see here, the dark upper triangle represents the pump. The circle is represent the hydraulic pump. The arrow at 45 degree represents the variable flow rate per shaft rotation, while the curved arrow represents the direction of shaft rotation. The arm letter inside the circle represents the electric motor. Here are the advantages and disadvantages while using the hydraulic pump. So let's look at the advantages first. Firstly, hydraulic pump can produce a lot of power in a small space, as they use the pressure of the fluid to generate force. Hydraulic pump can operate at high pressure, which allow them to handle heavy loads and perform complex tasks. Hydraulic pump can provide precise control and smooth operation, as they can adjust the flow and pressure of the fluid according to the demand. Hydraulic pump can easily be maintained and repaired as they have simple structure and component. Although it has many advantages, let's look at disadvantages of the hydraulic pump. Hydraulic pump can leak fluid, which can cause mess, waste, and environmental damage. Leaking fluid can also reduce the efficiency and performance of the system. Hydraulic pump can be noisy as they generate vibration and sound when operating. This can affect the comfort and safety of the workers and the surroundings. Hydraulic pump can be affected by temperature and viscosity of the fluid, which can change the characteristic and behavior of the system. This can lead to instability and inconsistency in the output. Lastly, hydraulic pumps can be expensive as they require high quality materials and processing accuracy. They also consume a lot of energy and resource to operate.
Next, I want to present about safety precaution for the components. Okay. First and foremost, safety precautions for hydraulic pumps are to involve proper maintenance to prevent leaks and need to ensure the integrity of the system. We also must do regular inspection, such as follow the recommended pressure, including temperature limits and fluid checks. Okay. Besides, safety procedure must also be in place to protect staff and workers from high pressure hydraulic fluid, which can be dangerous if it escapes from the system. Differentiate about hydraulics and pneumatic components. Okay. In hydraulic components, usually they use incompressible fluid such as oil, while pneumatic components use compressible, which is gas. As we know, hydraulic are known as a higher power and precision, while the pneumatics are often lighter and used in application that is high risk of explosion. Okay. For the system, hydraulic can be measured due to potential oil leaks, while the pneumatic are generally cleaner and more environment friendly.